Hello students, in last lecture we have seen the introduction of IC engine component. We have seen the different component, their functions, so how they work, and according to that work we can select, or we can say we can decide the criteria for the design, right? Next is we have discussed that difference between wet cylinder and dry cylinder, and today we are going to discuss a design of cylinder and cylinder head. So this is the first part of the design for the IC engine component. So this is the first component that we are going to design, that is design of cylinder and cylinder head. So these are the things generally in this cylinder and cylinder head. First is cylinder stroke and bore. You might have heard this word. Cylinder stroke means stroke length and bore diameter. Okay, so let's see over here what is cylinder stroke. It is denoted as L, and bore diameter it is D. So we have a one assumption, L by D ratio. Okay, so length to diameter, but this is a stroke length and this is a bore diameter. So L by D ratio is the we have to assume L by D in between 1 to 2 for IC engine. Okay, so here if you see, the L by D ratio is equal to 1 for air-cooled aircraft engine. If there is an air-cooled aircraft engine, then L by D should be the 1. And for all other engines, means almost whatever the examples we are going to do in the next lecture, almost we are selected L by D ratio 1.2 to 1.35, means this is the assumption that we are going to make. Now, few terms over here that you have heard in IC engine subject. Okay, so first one is indicated power of engine. So what is indicated power? Okay, so indicated power is the power generated inside the engine cylinder. Okay, piston, above the piston there is a spark and there is a blast, and due to that blast some maximum power given to the piston, that is called the indicated power. IP is equal to plan PLAN upon 60 into 1000. This you are aware of this equation IP. Okay, now brake power, you also know the brake power, the power generated at the crankshaft, that is called the brake power. Okay, so mechanical efficiency is equal to brake power upon indicated power. Okay, so these all are the terms. You can pause the video and see this all the terms. Okay, like efficiency, then mean indicated pressure over here, this is a mean indicated mean effective pressure, sorry, Newton per meter square. You should also consider the unit. You should know the unit, you should remember this unit, all the units. Okay, so cylinder bore, area, all these things, just pause the video and note it out. Okay, next is brake power is equal to indicated power into mechanical efficiency, that we have seen over here. Then brake power is equal to PLAN upon 60 into 1000. Okay, indicated power, we have the put the equation over here into mechanical efficiency. So we can find the brake power or anything from here. Almost we have to find the brake power. Okay, now after find out the brake power, we get the PBM, mean effective pressure. So maximum pressure we have decided that the 10 times of PBM. This is an assumption. Okay, now after solve of these equations, then we have to go for the select the thickness for cylinder wall. So you can see here, this is the thickness of cylinder wall. If we talk about the thickness, then this is the thickness of cylinder wall, this is the thickness of flange, and this is the thickness of head, cylinder head. Okay, this is a cylinder flange, this is called the flange, and this is called the cylinder thickness. So let us see how we can select these all the things, but before that we should know that which kind of stress is induced in the cylinder wall. So here 1 2 3 4, you can pause the video and read out this. Circumferential stress is there, longitudinal stress is there, radial stress is there, bending stress is there. So this kind of stress is generated inside the cylinder wall. Okay, now you okay, so you are aware of this figure, right? Now next is how we can find the thickness. Our question is to find out the thickness of cylinder wall. So here this is a circumferential stress, or we can say stress around the cylinder wall, that is PD by 2T, okay, and this is a longitudinal stress PD by 4T, and this is a radial stress is equal to minus P maximum. You have seen this equation, you have derived this equation in the pressure vessel design, in the subject design of mechanical engineering, okay, design of machine element, design of machine element. You have derived this equation in the pressure vessel, right? So in this particular IC engine you have to remember this all, or you can say you can see in a design data book whether this equation is available or not. So finally, circumferential stress that we have to consider, and by using that circumferential stress we got the equation of find out the thickness, P maximum into D upon 2 sigma C. Plus C1 is required because it is the reboring factor. We have considered reboring factor C1. Okay, these all terms you can pause and read it out. Okay, almost you aware of these things, but there are so many assumptions over here, like sigma allowable. So you can assume sigma allowable tensile stress per cylinder wall is 35 to 70 Newton per mm square. If you are going to do example and if you select 50, then it's okay. 50 is it's also okay, 40 is also okay, 45 is also okay. There are no answer answer is doesn't matter for this. Okay, you can assume whatever you want if it is not given. Okay, so here reboring factor with the different cylinder bore, there are different reboring factor is given here, and T should be greater than or equal to D upon 15. This ratio is also you have seen in design of pressure vessel. Okay, D by T ratio. Okay, now so your T should be greater than or equal to D upon 15. This should be, you should take care while design the while doing the example. Now thickness of cylinder flange, so TF. Now we are talking about cylinder flange, TF, this one. Okay, you can see here TF. So for find out the TF, directly you have to assume that 1.2 to 1.4 T, it's a 1.2 times or to 1.4, say average 1.3 T. Okay, so for TF you have to directly assume that 1.3 T. Now next is cylinder head. So material used for the cylinder head is grey cast iron, alloy cast iron, okay, containing nickel and chromium, because nickel and chromium having the high resistance, high wear resistance, high temperature resistance. Okay, so mostly we add the nickel and chromium for the cylinder head. Now for the flat cylinder head we have to assume the flat cylinder head, and we have equation for the flat cylinder head. TH is equal to K1D under root P max upon sigma allowable. So sigma allowable I have already talked to you, that 35 to 70 that you have to assume. P max that we have to find, we can find from above equation, and we have also assumed that P max is equal to 10 ppm. Okay, you can see. Now K1 is constant 0.3 to 0.4 we have to assume, and this equation you maybe get in design data book, or it may be not over there. If there is not given, then you have to remember this equation. Okay, now diameter of the bolt and stud. Okay, so now you have to remember machine design and industrial drafting, in which we have this equation. Okay, so there is no need to elaborate this equation how it's come, but we have to compare the things. Compare means what? We have to compare the maximum pressure produced inside the engine cylinder, and here is equal to this is equation for the stresses in the bolt. Okay, so it should be equal. Okay, so here by this equation we can find out the core diameter of the bolt. Okay, so here this equation is not new for you, and this equation is also not new for you, but you have to compare this both equation, and from this both equation you can get dc is equal to d under root p max upon n sigma tb. Okay, now if here consider for the n number of bolt or studs, you have to assume these things. Okay, d by 100 plus 4 to d by 50 plus 4. D is equal to the diameter, bore diameter. Okay, so there are so many assumptions here. I told you too much time, so you have to take care of assumptions, and parallelly you have to see in a design data book what is given, what is not given, and what you have to remember, what not remember. Okay, now the diameter of bolt or pitch circle and flange dp is equal to d plus 3 db. Okay, diameter of bolt, this is db, diameter of bolt. Now do, outside diameter of flange or cylinder head, is taken as do is equal to dp plus 2 db plus 12. Then pitch of the bolt. So here for the pitch of the bolt, one more assumption here, it is in between 19 under root db to 28 under root db. Okay, and so many assumptions here, but when we are going when we are doing example, during the example you will know the many things. Okay, so this is the this now example is there. So this is the procedure for design of cylinder and cylinder head. Okay, so today I think you should prepare well of this theory. Next time we will learn example for the same theory. Okay, so thank you very much. If you have any question or any doubt, you can ask me in WhatsApp or maybe call. Thank you. Jai Hind, Jai Bharat.